This is a STEM chat on the nature of sound. So this video is going to be about your introduction to sound waves and how sound is produced. So the key questions for today are going to be 1, what is a wave? 2, what propagates a wave? 3, what is a longitudinal wave? And lastly, 4, what are the characteristics of a longitudinal wave? So let's jump on into this. So the first thing that I want to take a look at is the nature of sound. So what exactly is a wave? Okay, you might think of a wave as in a wave in the water, and you're right, that is a type of wave. But a wave is going to be any sort of disturbance involving the transfer of energy from one place to another, or from place to place. Okay, just like if a drop of water were to drop into a puddle, this would be a disturbance. Okay, so you're pushing on something and you're pushing it away. Okay, it creates a disturbance and it transfers energy, and energy is going to be anything that is able to do work. Now, waves need something to travel through, such as a medium. So in the case of the water droplet, that's going to be the medium, is the water, which is the material that the water, or in which the wave is going to travel through. That energy has a mode or something, a medium to travel through, and it's going to be doing it through a wave. Now, sound waves can travel through air, water, and even solid materials. Okay, so sound waves need a medium to travel through. They can't travel through a vacuum. It needs some sort of particle, solid, liquid, gas, in order to be able to travel. Now, what causes a wave? Like I said earlier, what is energy? Energy is going to be the ability to do work and cause change. So you run up a hill, you need energy to do that. And then energy is released as you were to go down the hill because you're losing potential energy as you go back down. Any sort of work that is done requires energy. Now, energy is needed to make a wave, and then mechanical waves form when a source of energy causes a medium to vibrate. So as soon as something starts to vibrate, then that energy, it needs energy in order to cause the vibration, and then it's kind of like a domino effect that ends up moving that energy within the wave or the mechanical wave. If we take a look here, as this drummer, as he hits the drum, he's causing a vibration. He's putting work into the drum, and then the little panels on the drum start to vibrate, and then it pushes the air particles out. It compresses air particles, and then it also decompresses or makes a rarefication in the air particles, which is going to be our type of longitudinal wave. So again, like I said before, there's two main types of waves. Okay, light waves are going to be transverse waves. We're not necessarily focusing on that. That's like when you take a jump rope or a rope and you kind of go up and down with it. Where a longitudinal wave is going to be compressions, and then it's going to be rarefications where it's not as compressed. Similar to like a slinky, if you were to flick it, and then it's going to compress and decompress throughout, in which the vibration in the medium is in the same direction in which the wave travels, where in the transverse wave, we end up getting the motion perpendicular, okay, or at 90 degrees to the direction of the wave. Now, sound waves begin with vibrations, okay, and similar to like if we watch this video about the guitar string, notice that here you see and hear the guitar strings, right? So the guitar strings start to vibrate and then they push those air particles out, which is then creating the noise or the sound that the guitar is making here. Now, lastly, let's go over some key vocab here when it comes to sound waves. So compressions, okay, particles and the medium are close together in the vibration. Okay, we've got over in this image here, we've got the air particles that are really close together. Okay, as well as in the slinky, we've got our slinky particles, which are really close together. Our rarefications are when in a wave that they're spread apart. Okay, so we've got our rarefication in the slinky, we've got our rarefication in the particles. Notice this is a tuning fork after it's activated or you like hit it against your shoe. Amplitude is how compressed or rarefied the medium becomes. Okay, so the larger the amplitude, that's going to be the louder the sound, okay, because it's going to be more compressed particles and then it's going to be more spread out particles because it's going to be you're putting more energy into the wave. And then lastly, the wavelength is going to be the distance between equal points between different compressions. Okay, so if we were to take a look down here at the slinky, notice that we look at identical points in the wave. So the slinky is compressed here and it's compressed over here. So that's going to be our wavelength, okay, or the distance between two equal points within a longitudinal wave. That's our video on the nature of sound. If you missed anything from this video, feel free to go back and watch it again and watch it and pause it as many times as you need.